Dear students, in this video we are going to see the experiment number 5 multi-layer perceptron for the course 20CS 2032 Machine Learning Techniques Lab. To start with the algorithm, first we know what is the difference between single layer perceptron and multi-layer perceptron. Single layer perceptron mainly used to work with the linearly separable data. So if our data set is a non-linear data, then we can go for the multilinear perceptron. And then in single layer perceptron, we have only two layers, that is the input layer and the output layer. The output layer perform the computation. There are two types of computation. The first one is the summation. The summation represents the summation of the input and the weight between the input and the output. And then we have the next computation, that is the activation. The activation function decide when to produce the output in the output layer. And now we are going with the multi-layer perceptron. So multi-layer perceptron, at least there are three layers. That is the input layer and output layer, and in between we have a hidden layer. There are one hidden layer or more than one hidden layer. So multi-layer perceptron is a fully connected feed-forward artificial neural network which has at least three layers: input, output and one or more hidden layers. The hidden layer and the output layer will perform the computation here. The input layer just get the inputs from the user, and the hidden layer and the output layer do the computation. The computation includes summation and the activation. Suppose we are considered this is our data which have three input features: sepal width, petal length and the petal width. So the input layer contains three nodes which represents the sepal width, petal length and the petal width. And each node from the input to the hidden, we have the weights. Suppose we are considering this as 1, 2 and 3. So we have W11 and then W12, and this will be W13 and W14. And same thing, it is connected with the next node, this input X2, which is connected with W21 and W22, W23. So like that, we have a different weights for the node 3 to the hidden layers. And from the hidden layers, we have output 11 and then output 12. So like that, we have output 21 and the output 22 and 31, 32, 41, 42. So every nodes, it will do the computation in the hidden layer and the output layer, which will take the summation and followed by it will produce the activation. And these inputs are given to the input node. The initial weights are assigned, and based on the summation we have to do the calculation, and then the activation will be producing the output to the next layer, and that step will be repeated. So here the weight updation will be done in the forward direction. And here we have two output nodes in the output layer, so which will be used for class 1, that is iris setosa, and this will be producing the output for class 2, iris versicolor. The multi-layer perceptron will be using to solve the problems like classification and also regression. So in case of regression, we have only a single output node. So based on the input, we are predicting the numerical output variable for the regression problem. The first step of the algorithm is the initialization. So here the weights between the input layer to the hidden layer and the hidden layer to the output layer get initialized, and the biases also initialized with the random values. And the next step is the forward propagation. The input data will be passed through the network, and each neuron in the hidden layer or in the output layer will do the weighted total sum of the inputs. and then it will be applied to the activation function. Based on that, the output will be going to the next layer. The next step is the error calculation. So the computed output and the actual output, we are calculating the error. So based on the error, the weights get propagated in the backward direction. So in order to reduce the loss in the error, we are going with the next step called as back propagation. Once the error is computed, to reduce the error, the network modify the bias and the weights through some optimization techniques during the backpropagation learning by using the learning algorithm called as gradient descent backpropagation learning algorithm. The backpropagation algorithm calculates the gradients of the loss according to the network, and based on that it tried to modify the bias and the weight in the backward direction during the backpropagation phase. And during the training, we are going to do the forward propagation, the loss estimation and the backpropagation process in an iterated manner for the specified number of iteration or until the network converges with the small error value. And during the training, the hyperparameters also modified in order to optimize the outcome of the network. The parameters include the learning rate, number of iterations and the activation functions, etc. And the last phase is the prediction phase, and by using the forward propagation, we have the trained weights and the biases. So now the unknown inputs will be given, and based on that, the prediction will be happen in the testing phase. This animation helps you to understand how the MLP is working. So during the forward propagation stage, the input is fed in the input nodes, and based on that the weights are updated and the output will be activated in the output layer. And in the second step, we are calculating the loss function. So now the error function is calculated, that is the difference between the predicted value and the actual value. So based on the loss calculation and using the gradient descent algorithm, during the backpropagation phase, the weights and the biases get updated until the network get convergence with the reduced error. And the algorithm steps to follow, since you know the MLP can be used for both the regression problem solving and also it can be used for the classification problem solving. And this is a data set which will produce the regression. So these are your input attributes and this is the output attributes we need to predict. And in case of the classification, and this is our target and these are our input arguments. And first we need to identify the type of the problem you want to solve, whether it is a regression or the classification. Then you identify what are the input attributes and your output attributes to be concentrated. If there is any missing value, do the data imputation using a mean. And next step is we need to standardize the input attributes. The thing is we have a different values with the various range. Here you can see the bedroom will have the range of some 2 to 4. But square feet of living, it is ranging from 770 to 2570. So you want to perform a standardization so that it will scale your data with zero mean and the unit variance. And the next step is the label encoding. If your data having any categorical variable, it needs to be converted to a numerical variable. So here also the target, we have the categorical variable. So that will be labeled with 0 or 1 depends on the class label. Then we have to split our data into training and the testing. And to start the training phase, we need to initialize our network parameters like the number of epochs, learning rate, the initial weights and the initial bias value. Now start the training process. Take each instance in every epoch and compute the weighted sum. Apply the activation function. Basically in MLP, we are using the sigmoid activation function. And at the output layer, compute the error, and based on the error, we have to re-update the weights using the backpropagation learning rule, that is the gradient descended weight updation rule. So once we have completed the training process, print the final weight after the training. And also we have to plot the loss curve. The loss curve represents for every iteration how the error get reduced from the initial iteration to the iteration. So this is our loss curve, this is our error, and this is the number of iteration. And once we have learned the weights of our network, now we have to move to the testing phase. There you have to send the unseen data so that your system will predict the output. And finally, we have to evaluate the performance. If it's a regression, you have to calculate the mean square error and then R2 square error. And if it's a classification, we need to compute the accuracy, precision, recall, and the F1 score. And this is a Python code which will help you to do the solving problem of the regression. So to do that, first we have to import the MLP regressor. And we have to follow the steps of identifying the input attribute, output attribute, cleaning our data, and then we have to standardize our data. So once you standardize your input data, then we divide our data into training set and the testing set using the train test split function. And now we have to initialize our parameters, how many hidden layers we need. So this having 2 hidden layers in between our input and the output. And each hidden layer, how many nodes need to be kept. So first hidden layer 150 nodes, second hidden layer 100 nodes, and third hidden layer 50 nodes. Input layers contain how many input features you have, that much number of input nodes we will have it. Output based on the output. The regression means you want to predict a single value. Classification means based on the class we have to give the output nodes. And maximum iteration need to be followed. Then what is the activation function we are using and the optimizer we are using, and that information we have to initialize in the MLP regressor. And once it is done, we have to train it by using the fit function, and finally we have to predict by using the predict function, and we pass our test data, so the predicted value will be there. And we can plot the regression curve by using a parameter called as loss curve. And now we want to tune our hyperparameters. So hyperparameters only determine the behavior and the performance of our machine learning model. So basically the learning rate and the number of iterations. And we can optimize the activation function and the solver optimizer what we can use, so that all you can optimize using the hyperparameter tuning. And these parameters are not learned during the training phase. So instead it will be set prior to the training phase. And why we need to do this? We need to find the optimal values for these parameters. That's why it is called as hyperparameter tuning or the optimization. And there are 2 types of hyperparameter tuning. One is a grid search algorithm and another one is the randomized search algorithm. In grid search algorithm, every combination of our hyperparameters values are tested and evaluated to improve the performance of the model. So it is a heuristic search. So it will search all combinations of the hyperparameters and try to find out which is the combination is the best hyperparameters. But in randomized search, we will take some sample values of each hyperparameters and train the model with the sample values. So it will not explore the entire search space, but it will search only in a selected subset. So it will try to reduce the time when compared with the grid search algorithm. And if I want to do the hyperparameter tuning for my multi-layer perceptron, so these are my parameters need to be tuned. I can vary with different hidden layer size and the number of iterations, because it tried to provide a combination of all these combinations are available in the search space. It will take every combination and try to run the algorithm and identify which hyperparameter combination is the best combination. And various alpha value, learning rate, solver, activation function. So every combination, it will do the training and it will identify which combination of the parameter giving the good performance. So we have to have a grid search CB. We pass our MLP regressor and based on the parameter, it will do the grid search. That is exhaustively search all the combination of the hyperparameters. And finally, it will display what is the best parameter combination from the hidden layer, activation, solver, alpha and the learning rate. And finally, by using that, you can predict your outputs by passing the unseen data. Same way, we can tune the hyperparameters using the randomized search. So here also we are initializing all the hyperparameters and by using the randomized search, it will randomly select some subset out of the parameters and do the computation for that. So by using the randomized search function, we pass our MLP and then these parameters will be passed. So the randomized search algorithm take a random sample from the hyperparameters and it will try to optimize that parameters and that will be given to the training set for the training and the best parameters will be displayed and finally we can predict our test output. And suppose we want to work with the problem of classification. Then we have to import the MLP classifier and follow the same step. Get the data, identify what is input attribute, output attribute, clean our data and then standardize our data, divide our data into training and testing, then initialize the classifier with the hidden layers, maximum iteration and the random values and use the fit function for train your data and use the predict function to classify your unknown data and display the loss curve. Here also you can use the grid search and the randomized search in order to optimize the hyperparameter before the MLP will be given for the training purpose and the testing purpose. I hope this video is useful for you to understand the basic working principle of the multi-layer perceptron in order to solve the problem of the regression and the classification. Thank you.